Hello and welcome to the 17th video lecture of Quantitative Analysis for Business Decisions QABD semester number 2 model number 2. Today we are beginning with model number 2, that is measures of central tendency. In today's video lecture we are going to see about the requisites of good average. But before beginning into what is an average, what are the requirements? Requisites means requirements. So what are the requirements of a good average, or what are the characteristics that the good average should possess? We shall see one concept that we had left out in our model number 1, that is converting an inclusive class interval into an exclusive type. See, I had already told you in our previous lectures that in statistics, whenever we want to apply any formula in statistics, all those formulas are based upon exclusive class interval. So if they have not specified what type of class intervals it is, you have to assume that it is exclusive type itself. The reason is because all the formulas that are there are applied to exclusive type of class intervals. Inclusive and exclusive types, the difference we have already seen. In inclusive type, what happens is, suppose this is an example of inclusive class interval. The lower limit of the class interval as well as the upper limit of the class interval here, both are included in this class interval. That is, the lower limit and the upper limit, both are included. So if you say 19 will fall under come in this class interval. If you say 29, it will come in this class interval, and so on. So both the upper limit as well as the lower limit come in that specified class interval. So this is an inclusive type. Exclusive type is something like 10 to 20, 20 to 30, 30 to 40, 40 to 50, and so on. So what happens here is only the lower limit is included, whereas the upper limit is not included in the class interval. Suppose if 20 comes, then 20 will not come here, 20 will come here, because here in exclusive class intervals we exclude the upper class limit. That is, we only include the lower this limit, and this whatever is there, that is the upper limit, is included in the next class. So whenever we read this, we read it as 10 to less than 20, 20 to less than 30, 30 to less than 40, and so on, when it comes to exclusive class intervals. So let us see how to convert. Suppose if you are given an inclusive class interval itself, how to convert an inclusive class interval into an exclusive type. That is what you have to do. So how to do this? So example is given here. Suppose this is the frequency distribution table that has been given to you. You have to convert this into an exclusive type. Only when you convert this into exclusive type, then only you can apply formulas such as median and other things which you are going to study later in this model. So now let us begin. First, analyze what is the gap between this and this, that is the upper limit of this class interval and the lower limit of this class interval. Is this the same? First you have to see. In this case it is same. What is the difference? The difference is 1. This one has to be divided into two parts. So if I equal parts, two equal parts, so it becomes 0.5 and 0.5. okay, the gap is 1. Suppose if the gap was 2, we would have divided that gap into two equal parts, that is 1 and 1. Generally the gap will be 1. So in this case also the gap is 1. 19 to 20, the gap is 1. This gap, this gap is 1. So this has to be divided into two equal parts, that is 0.5 and 0.5. This 0.5 is added everywhere here, so this to the upper limits. So this becomes 19.5, 29.5, 39.5, 49.5, and the same is deducted from this part. So this becomes 9.5, 19.5, 29.5, and 39.5, and we get this 9.5 to 19.5 19.5 to 29.5, 29.5 to 39.5, and 39.5 to 49.5. So this is how we convert inclusive class intervals into exclusive type. Okay, what we have done is, I'll just show you this. We have analyzed what is the gap here. The gap here was 1. Generally it will be 1. Divide this into two equal parts, that is 0.5 and 0.5. So what we are doing is we are adding 0.5 to all these values, and we are subtracting 0.5 to from all these values, and we'll get this. Remaining frequencies and all will remain the same, unaffected. So this is how we convert an inclusive class interval into an exclusive type. So after knowing this, let us move towards central tendency. So what is a central tendency? By definition, it is the tendency for a set of values to gather around the middle of a set. So whenever, suppose if I am giving you certain values, suppose if this is a number line, say 0, 1, 2, 3, 4, and so on. So these are the values. So generally most of the values will come around a certain, most of the values will be somewhere around a central part, that is they will gather or they will concentrate in a some central portion. This central portion is known as the average, and this tendency of or characteristic of a set of values to gather around a central or concentrate around a central part or the middle set or middle of a set is known as central tendency. It gives us a single score that is most representative of the entire set. So if you just give the idea, suppose a height of 10 students in inches, then it becomes difficult for you to analyze. But instead of that, if you say the average height of those 10 students is 5 feet 6 inches, then you'll get an idea about what might be the somewhere means an idea about the height of the students, those 10 students. So this is the reason it gives one single representative number that can quantify the entire set. So this is central tendency. This central tendency is a tendency of a set of values to gather or concentrate around the middle of the set or somewhere around the mid portion of the set. So let us move towards the next thing, requisites of a good average. That is, what are the requirements or what are the characteristics of a good average? Since an average is a single value representing a set of values, it is desired that such a value satisfies the following characteristics. These are certain characteristics which any good average should satisfy. First one, it should be easy to understand. Since statistical methods are designed to simplify and to quantify the problems or to simplify the complexity that is there in the data, it is desirable that an average is such that it can be easily understood by everyone, including the common person. Secondly, it should be simple to compute. Not only an average should be easy to understand, but also it should be simple to compute, that is calculate, so that it can be used widely in every aspects of all the subjects. However, though ease of computation, that is ease of calculation, it should be easy to calculate, I'm saying, so it is desirable, but it should not be got by losing some other things like accuracy. If you're losing accuracy and getting easy methods to solve these problems, then it is of no use. So accuracy is also desirable, certain important things. So you have to take into consideration that aspect also. It should be easy to compute also, and it should be give you accurate results also. Next, it should be based on all the items. The average should depend upon each and every item in the set that is given, such that if one of the item or if one of the value is removed from the set, the average that you got of the remaining numbers should be affected. That is, it should be changed. It should either increase or it should decrease. That means all the items are affecting the average. It should not be unduly affected by extreme observations. Although each and every item should influence the value of the average, but none of the items should influence it unduly. That means, suppose if the values are, want to find out the average of uh, three students, the average marks obtained in statistics out of 10. The test is out of 10. Three students are giving that statistics test. The first person has scored 1 mark, the second person has scored 1 mark, and the third person has scored 10 out of 10. When you take the average marks, it becomes 10 plus 1 plus 1, that is 12, divided by 3, that is 4. So you say 40% is the result, or 4 marks they have got on an average. So in this case, what is happening is unduly, and that is one observation which is very high, that is affecting the entire value. If that observation would not have been there, the average would have been 1, right, of this data set. So in this case, what happens is certain outliers are there. Now what are these outliers? Outliers are those items which are very high in value compared to other values in the data set, that are affecting the central tendency, or they are affecting the average, mean, median, or mode of the entire data set. So outliers are those numbers which are on quantitative wise or numerical value wise, they are very high or very low compared to the other values in, or compared to most of the values in the data set. So these kind of outliers or extreme observations which are there, they affect certain times the averages. So such kind of things should not be there. Next, it says that it should be rigidly defined. An average should be properly defined so that it has one and only one interpretation. It should preferably be defined by an algebraic formula. So it should have an algebraic formula, so that if different people are calculating averages at different times in different places with the same numbers, they should get the same average. The average should not depend upon personal prejudice and bias of the investigator or his own interpretation. Otherwise the results will have no meaning and they can be easily manipulated. It should be capable of further algebraic treatment. We should prefer to have an average that could be used for further statistical computations or calculations, so that it can be used in more and more subjects and it has more utility. Graphs and tables, as we know, they do not have any further arithmetic treatment or any algebraic treatment that can be done. So algebraic formulas which are there in averages should be used such that they can be used for other further algebraic treatment. That is, you can find out square of those means, you can use those means in some other formulas and certain other things also, so that its utility or use is more. And lastly, it should have sampling stability. Last but not the least, we can say that we should prefer to get a value which has what the statisticians call sampling stability. This means that if we pick 10 different groups of college students and calculate the average of each group, we should expect to get approximately the same value. It does not mean, however, that there should not be any difference in those 10 values. There may be some differences, but those samples in which these difference is less are considered better than those in which the difference is more. So after this, the requirements of good average, we'll see measures of central tendency. So what are the various measures that we are going to study of central tendency? Central tendency or the average, remember one thing, that average, this word is used for central tendency. Average does not mean mean. Okay, it does not mean only mean, it may mean, okay, average is, can be a mean, it can be a median, or it can be mode also. Many people make this confusion that they feel that average is and mean are one and the same. It is not the same. Average is this and this, all three things. So it can be any one of these three things. Central tendency or average is mainly divided into two things. One is the mathematical average and the other one is positional average. Mathematical average, we have one important thing, that is mean, in which we have arithmetic mean, geometric mean, harmonic mean. These are three means that are there, but in your syllabus you only have arithmetic mean, that is AM. On the other hand, positional average, we have two different things, that is median and mode. So what are these? We are going to see one by one in the coming slides. Central tendencies, certain key concepts which you should know. The three principal measures of central tendencies that we have just seen are mean, median, and mode. The measures for a simple for sample can differ from those from the whole population. That is, suppose there is a population. hmm? Population is an entire set of people who are related to a particular problem. Then out of that you pick up certain sample, say 10 people you are investigating. Then what does it mean? uh, the mean of the sample can be different from the mean of the population. Okay, this is little what you are going to study in market research also. For the time being, you only remember that there are three measures of central tendency, that is mean, median, and mode. The mean is the sum of the values in a set of data divided by the number of values in the set. So mean is arithmetically defined. We know that it is an arithmetical average, and hence it is arithmetically divided described as it is the sum of all the individual values divided by the total number of values. So that formula is written as mean is shown as x bar is equals to sum of all the values is summation x upon number of values, that is n. So x bar mean is equals to summation x upon n. Next, the median is the middle value or the middlemost value of a data set. So suppose if there are five values arranged in a certain order, 1 2 3 4 5. Suppose these are the five values, these are arranged in ascending order, so this is known as a data array. How to find this we are seeing in the later. So which is the middle one number? This and this goes, this and this goes, so the middle value is this, so your median is this. So middlemost number is nothing but the median. What is mode? Mode is the most frequently repeating number. Suppose your numbers are like 16, 17, 17, 18. So out of this, which is the most repeating number? This is repeated once. That is two times it has occurred. One time. So this is known as mode because it is repeating the most in this case. uh, Outliers, just now what I have explained, can have a dramatic effect on the mean if the sample size is small. Generally outliers have a very big effect if they have exceedingly high or exceedingly low value compared to other values in the data set. So they will affect the value of the mean. That is why mode and this median may be used in such cases where there are chances of having outliers. Mode and median, being positional averages, are not affected by outliers. The weighted mean, again we are seeing this. If you're getting confused in entire this set, it's okay, because in detail we are seeing this point wise with explanation in further slides along with numerical examples. The weighted mean can be of useful measure when all the data are not of equal importance. Suppose uh, if there are suppose subjects, five subjects are there for you, suppose, and out of that two subjects are not of that high importance. So your subjects can be given certain weights. Four for math, suppose maths is there, four for mathematics, physics is there, three for physics, then statistics is there, two for two for statistics, and then there are certain subjects where you have little less importance, say some subject x and subject y, so they have weightage of 1 and 1. If you take these weights into consideration, then you can find out weighted average mean. How to find weighted average mean I have explained in the further slides. For data grouped into intervals, the mean and median can be estimated using the midpoints and frequencies for the intervals. Again, these things I have explained to you. So in this slide, if you see, what are the main important things? The only main important things are, you should know that there are three measures of central tendency, then definition of mean, definition of median, and definition of mode. Mean definition is this, median definition is this much only, and mode definition is this. Whatever I have underlined in this, only this if you know, that is more than enough in this slide. So with this we end today's lecture. If you have any difficulties, you can always contact us.